So the first property that they go over in the book, because it's really the property that we're using in order to simplify radicals, you're going to turn around and use it later in this section to actually multiply them back together, is basically if we have a radical, say, square root of 54. Any radical can be broken up into a product of two radicals, or more, actually. So if you look at 54 and you're like, hey, 54 is 9 times 6. If we wanted, we could break this up into two radicals that are 9 times the square root of 9 times the square root of 6. And the benefit to doing that is if you know that there's a perfect square in 54, and sometimes it's easier with the smaller numbers, and you know, hey, 9 is a perfect square, and that's in there, we can break them apart. And 6 is only 2 times 3, so there's no perfect square in there. But 9, the square root of that is 3, right? So we can break them apart and say, well, then this would be 3 times radical 6. Okay? And basically, this property, the multiplication property of square roots, tells us, hey, you can break them apart into their factors if you want. Well, later on, we use the property and we actually go backwards. If you had a reason to want to multiply these back together, we could say, well, the square root of 9 times the square root of 6 is the square root of 54. Now, there would be no purpose in doing that for this one because you always want to simplify your radicals anyways. So simplified, it would be that, okay? So one of the first things you want to consider, okay, is there are no perfect squares inside the radical, and the radical is the square root bar. Okay, no perfect squares inside the radical. If there are, it is not simplified. So our goal is always to simplify those radicals. You will not be picking up your calculator for this unless you don't know the factors of a number. If you're just looking for the factors, that's fine. But you will not be taking the square root of a number and writing down a decimal, okay? So we kind of started talking about this a little bit yesterday, but if you have, for instance, 192, okay, there are two ways that you could go about simplifying that radical. If you know what the perfect square in there is, you could take out the perfect square times the other factor and do it that way. The reason I don't focus a lot on that method is beyond the smaller numbers, most people don't know what the perfect square factors are, so you're kind of wasting your time to just sit there and think through all the possibilities. I'll show you that method kind of off to the side in a minute, but for me, I think it's quicker to just do the tree, okay? So you're going to do the tree and say, all right, I know 2 goes into 192, and if you don't know how many times, then you can use your calculator, but that would be 96. And you circle the primes. You don't want to lose track of your primes, okay? And then 96 would be 2 times 48. Okay, circle the 2, that's prime. And then we have 2 times 24, 2 times 12, 2 times 6, and 2 times 3. Okay, now at this point, it is up to you if you want to write it in exponential form or if you just want to list them out. Okay, usually I list them out. So we have 1, 2, 3, 4, 5, 6 2s and a 3. Yes?
For 12, couldn't you just like do 3 times 4?
You could, but then you'd still have to break down 4. I pull out the smallest numbers first because then they're all lined up nicely. Sometimes people, like, say up here at 48, you go, oh, that's 6 times 8. That's fine, but then you're going to have, you know, some of your primes might be up here. They're easier to lose track of. That's the only reason I pull out the smallest numbers, always. But as long as you don't lose track of your primes, that's the biggest thing, okay? So this would either be 2 to the 6th times 3, or if you're more comfortable saying that's 1, 2, 3, 4, 5, 6, and 3. Okay, what you're looking for are those pairs. Anything that's a pair, or if you do the exponential form, anything greater than 1 has a pair at least, okay? So there's a pair, there's a pair, there's a pair. Now, if you did, we'll say or, if you said, well, that's 2 to the 6th times 3, then you're going to take out half of these, right? Because there are 6 of them, or 3 pairs, yes?
Yeah.
Okay, so this would be, the 3 stays in because that's not part of a pair. And half of those would be 2 to the 3rd. Or if you said over here, again, the 3 stays in, I have a 2, a 2, and a 2, so I'm still taking out 3 of them, right? So 2 times 2 times 2. Either way, that would be 8 radical 3. Okay, now if you did the chunking method, let me show you what that would involve. I don't bother with it often because I don't want to spend that much time thinking about it. You would have to know that 192 is actually 64 times 3.
Was it chunking?
What's the chunking method?
Breaking it into 2 chunks. One chunk is a perfect square, the other's not. Okay, so that means I know 64 goes into 192, 64 is a perfect square, so this would be the square root of 64 times the square root of 3, which would be 8 radical 3. But how many of you knew that 64 was a factor of 192? Then you might do chunking, okay? I don't care which method you do. The bottom line is that you can do this by hand without your calculator, okay? Now, if you happen to have a calculator that does this for you, you need to do it without that function, all right?
I'm really confused on the chunking part. Makes no sense.
We're using the fact that we can split this up into 2 factors, one of which is a perfect square, so we don't have to go through 64 is a perfect square because it's 8 times 8. So you would say, well, 64 is the biggest perfect square factor of 192. And then you'd split them apart and say 3 is not going to come out, but the square root of 64 is 8. I get the same result, arguably in fewer steps, less work. But the reason I don't focus on that is, out of all of you guys, one person raised their hand that knew that 64 was a factor of 192. So it's not worth the time stressing on it. If you understand this method, stick with that. Okay. There is one time where I always go with chunking, and I'll do one of those next. Okay, so the place where chunking would be beneficial is, say you have 500. Okay, 500 is 5 times 100, right?
Yeah.
And 100 is just 10 times 10. So you wouldn't bother breaking down 100 into its primes because 100 is a perfect square. Okay, so if you have any multiple, especially an odd multiple of 100, so if I have 500, that is 5 times 100. Okay, I'm not going to break 100 down because I already know that's a perfect square. So sometimes if you're in the process of doing your tree and you go, oh, that's 5 times 100, and then you go, oh, hey, look, 100 is a perfect square. Stop there, because 100 is really 10 times 10, right? That's a pair, although it's not prime, it's still a pair. You can stop there, because this is going to come out and it's going to be 10 radical 5. That's where chunking is beneficial. I usually, if I'm doing a tree and I go, oh, there's a 64 in there, I wouldn't break 64 down into all of its primes. You're going to have a whole mess of 2's, you know, and 64 is 8 times 8. So I would list it as 8 times 8 and count it as a pair. Does that make sense? All you're looking for are pairs, because we want to get them out of there, okay? Now, if you insist on, if it's too much to think of it that way, then go down to the primes. All right? Now, the next part we're going to talk about is the variables, and we kind of touched on that yesterday too. So when you have variable factors, you're still looking for pairs. Any factor that appears more than once in your radical is at least one pair and needs to come out, okay? So if we look at the square root of 45x to the 5th, okay, you're going to have the factors of 45 and 5 x's hanging out in your radical, okay? So 45, might as well break that down. That is 3 times 15, 3 times 5. There are my primes. And some of the smaller ones you might get pretty good at, and you'll go, oh, I already know 45 is 9 times 5, so that's 3 times 3 times 5. You don't have to do the tree if you already know what the primes are, okay? But in my radical, I've got 3 times 3 times 5, okay? And we've got 5 x's. One of them is going to stay in, right? So you can look at this 5 as 4 and 1, right? So that 1 is going to stay in, but we're going to get out the 4 and the 3's. So what actually do I keep in the radical? 5 and x. They are not part of a pair. Okay, so 5x stays in. The square root of this pair would just be 3. And half of those, square root of x squared, or x to the 4th, would be x squared, right? That means there are 4 of them. I'd get 2 out. So that is simplified. All right, so there are variations of these. So we're going to look at a couple more of those. Sometimes there's already something hanging out in front of the radical. So you're just going to worry about one part at a time. Let's take care of the 60 first. 60 is 2 times 30, 2 times 15, 3 times 5. So we have a 2, a 2, a 3, a 5, and you've got an odd number of A's. So I change this to A to the 6th and another A. So we're just taking the 7th one off, right? Yeah.
Can you zoom in a little, please?
Yes.
Thank you.
All right, So once you have this set up, we have a pair here and a to the 6. Okay, so inside my radical, it's easiest to get that out of the way first. I have a 3, a 5, and an a, right? You're going to multiply those back together. So this would be 15a. Now you could do what's next all in one step, but if it's too much, then just bring the step out. That 2, okay, is going to come out. So I've already got negative a here. That 2 is coming out. And what's coming out from here? A to the 3rd. Now I've got to deal with what this actually equals. Okay, the negative and the 2 stay out front. This is just multiplication, right? So this is going to be negative 2, and I have an a plus 3 more. So what would that be? I took 3 out. I already had 1 there. A to the 4th. And then my radical. And that's all you can do. That's simplified. All right. How about if there are only variables? Sometimes people get all weird about there's not a number in there. What am I supposed to do with that? There's still perfect squares in there. You still have to get them out. Okay. Well, put your radical. What actually, is anything going to be left in there?
Yeah.
A y, right? Because there's an extra y. So this is really y to the 4th and y, right?
Yeah.
Okay. So that 1 is going to stay in there. But then I'm going to take half of those out. So outside that would be an x, right? And half of those would be y squared.
That's all.
That's all. Okay, so far so good? Yes? Okay. So now we're going to use the property backwards. But I'm going to make a suggestion. Okay, basically, when you multiply 2 radicals, it works like a funnel. Okay, unless we're chunking and we're trying to simplify it. But multiplying them simply means you're going to put all those factors in together and take out the pairs. Okay, so all factors in one radical remove pairs. Some people, they insist that, well, I've got to do 8 times 12. That's 96. Why would you actually multiply 8 times 12 when you're going to turn around and break it down into its factors anyways? Do you know what I'm saying? You're going to learn probably pretty quickly that 8 is 2 times 2 times 2. So you get 3 2's out of 8. Okay, so 8 is 2 times 2 times 2. And since 12 is 3 times 4, that is 3 times 2 times 2, right?
Yeah.
Okay. Now, you don't have to put them in separate radicals, but for the sake of your notes, I want you to understand. I'm taking the factors of 8 and the factors of 12, And all these factors are going to be together. So I have 5 2s and a 3. So they're now, since I multiplied, they're all in one radical. So then I look for the pairs, pair, pair. So what stays in?
2 and 3.
Which make 6. And outside I get a 2 and another 2. Which would be 4.
What would be 2?
Okay. Now, of course, you're going to have some radicals that already have numbers in front, and we're multiplying them. So it's kind of, we're taking the commutative property and reordering things. Okay? So here's one of those. The only thing different we do here than what we did up there is the numbers that are already outside, they're going to go in front. It's all multiplication, right? So you're going to take these and bring them in front. And in the process, you can multiply them together. That's what I would do. Okay? But I'll move it up here just for the sake of your notes. But if you're like, yep, 3 times 4 is 12, then put 12 in front. Now, in my radical, I have a 2, right? And might as well take care of that 10. That's another 2 times 5, yes? And I have x times x. Now, if you want to call that x squared or just put x times x, either way is fine. I'll do squared, okay? So I've got this 12 out here. What stays in? Here's a pair, here's a pair. So 5 is in. I'm going to have to pull the 2 out, but the 12 is already there. So those are going to be multiplied.
4.
And half of those. Okay, so this would be 24x radical 5. And don't worry, like when you get negatives, sometimes people have trouble with those negatives. It's multiplication, so pull your negatives in front with your numbers. The ones that you won't have a negative inside a radical. They'll all be in front. Pull them all the way out front. If you have 1, then your answer is negative. If you have 2, then it's positive. Okay, so I'm going to have you guys try this next one. All right, see what you can do with that. So what's the first thing you do? Yep, you're going to do 2 times 6, pull it right out front. Okay, so 2 times 6 in front will give you 12. And in my radical, if I'm funneling all the factors in to 1, what do I have? I have a 5, and a 5, and a 2, right?
Does it matter?
No, I usually try and group the like numbers together. It makes it easier when you're looking for pairs. Okay. I mean, if I had 5, 2, 5, I'd still have a pair of 5s. They just wouldn't be conveniently next to each other to circle them. So that's the only reason I try and, if I know what my factors are, I try and pair them up if I can. And then x squared and x to the 3rd would be x to the 5th, right? But if you like having that oddball by itself, then we would do x to the 4th and x. Otherwise, if mentally you know exactly what to do with x to the 5th, that's fine. Okay. Or, I mean, if you wanted to list out 5 x's, knock yourself out, you can do that too. Okay. But I have a pair here and a pair there. So what is inside? 2x. And what's outside? I have 12 times 5 times x squared. And that can be simplified, so that would be 60x squared radical 2x. All right. And the next section should kind of be done, not section, but the other half of this, it involves the fractions. And that should be done kind of together in one day. It'll make more sense because you have to look at what your situation is. So I'm not going to get into the fractions today. So we're going to stop at this.